Alright gang, this is going to be a quick one, so let's just knock it out. We have learned to use the Pythagorean theorem and the law of sines and cosines. No, we've learned to use the Pythagorean theorem and Sohcahtoa when solving right triangles. Those two things only work in right triangles. We've learned how to use the law of sines, which is sine of A over A equals sine of B over B in any triangle where you have an angle side pair. So what's left is non-right triangles that don't have angle side pairs. The last thing we're going to learn is called the law of cosines. It technically works in almost any triangle. So let's start with this. The only triangle that can't ever be solved is angle, angle, angle. If you have an angle, angle, angle triangle, 30, 45, 105. If you have an angle, angle, angle triangle, these sides could be any scale. It could be 2, 3, 4, or 20, 30, 40. Because of that, angle, angle, angle triangles can never be solved. Every other type of triangle can be solved by law of cosines. However, it's kind of a pain in a lot of cases. You only want to use the law of cosines when you don't have an angle side pair. So really that means it works best in side angle side and side side triangles. So today we're learning law of cosines, but real quick let's review Sohcahtoa Pythagorean law of sines. Sohcahtoa is where we say that the sine of an angle, so say sine of angle A equals the opposite divided by the hypotenuse. And don't forget we can also say that the inverse sine of the opposite divided by the hypotenuse gets you angle A. That only works in right triangles. We've learned Pythag, which is a squared plus b squared equals c squared, also only works in right triangles. And we use the law of sines. Sine of A over A equals sine of B over B, and you can use that whenever you have an angle side pair. If you don't have an angle side pair, you want to use law of cosines. So here we go. Law of cosines starts very Pythag-y. C squared equals A squared plus B squared. But then it tacks on this extra minus 2 times A times B times the cosine of C. Now, this you have to recognize is one term. That's all together. So a common mistake that people make is they think at some point they can start adding a 2ab to both sides. But you can't just add 2ab to both sides, because it's being multiplied by this cosine c. That all has to stay together. So let me show you how this can work. I'm now going to delete everything on this page. Boom. This does not have an angle side pair. This triangle right here is missing an angle side pair. I'm going to have to create one, basically. I use the law of sines to create an angle side pair. So I'm going to call this angle A, and call this angle B, and call this angle C. And remember that the law of cosines is c squared equals A squared plus B squared minus 2ab times the cosine of C. Now, don't be confused. Don't think that because this C is right here, that corresponds directly to this C right here. That's not how it works. You're free to label the triangle however you want. You're free to rearrange law of cosines however you want. If I wanted to, I could call this A squared equals B squared plus C squared minus 2bc times the cosine of A. Or I could call it B squared equals A squared plus C squared minus 2ac times the cosine of B. All of those are ultimately the same. Okay, I'm just going to stick with this first one to try and be consistent and not confusing. Here's the key. I know this angle right here. I know that angle. That means I want to find this side. If I can find that side, I would then have an angle side pair. And I use the law of cosines to create angle side pairs. So even though this says letter A, I'm going to plug it in as my angle for C. And even though this says letter A, the key is whichever angle you're dealing with, that angle and its side are always going to be on the extremes of this equation. So I'm going to put the angle here, its corresponding side here, the other two sides go here. So you cannot be hung up by the fact that I'm not calling angle A angle C. Okay? You just have to get past that. And again, if it helps you, if you want to go through and relabel this, so that C is here, A is here, and B is here, that makes this side C, this side B, and this side A, that's fine. Go ahead and do that, it doesn't matter. Okay, so I'm going to stick with this new labeling I just created. C squared equals A squared plus B squared minus 2 times A times B times the cosine of C, and I know what C is, it's 18 degrees. Well, all of this can just be calculated. I'm going to again check to make sure that I'm in degrees, not radians. And I'm going to have 14 squared plus 10 squared minus 2 times 10 times 14 times the cosine of 18. Type all that in, 29.7. That is not side C. That is C squared. C squared equals 29.7. So C is going to equal the square root of 29.7. And notice how in my calculator, I'm not going to type in square root 29.7. I don't do this, because that causes me to round when I don't have to round. What I can do instead is just do the square root of my previous answer. That is the most accurate way to do this. Whenever you can, pull up your previous answer. On one of these fancy graphing calculators, you do that by pressing second, which is the top left button, and negative, which is basically the bottom right button, right below number 3. On other calculators, it might be different. You can maybe just scroll up and press enter, but that's 5.45. This length right here is 5.45. It makes sense that it would be a very small size because this is a very small angle. The smallest angle should go to the smallest size. It doesn't match the picture very well, but that's okay. Now, here's the thing. Now that we've found this side, we have an angle side pair. Do you see? Side C and angle C are now known. Now that we have this side, we have an angle side pair. So if I wanted to find, say, this angle right here, say I wanted to find, this little angle A, I could do that now with my angle side pair using the law of sines. I could say the sine of 18 over 5.45 equals the sine of A over 14. I would then solve that for A by cross multiplying and dividing, so it'd be 14 times the sine of 18 divided by 5.45 equals the sine of A. So now do the inverse sine of all this. These cancel each other, and I would just calculate that to find this angle. Once I found that angle, finding this angle would be very easy because they'd all have to add up to 180. So you should only need the law of cosines one time. After that, you should be doing the law of sines. Okay, this was us finding a side. And this is a side angle side triangle. We were given a side, an angle, and a side. I'm going to take this triangle here, which is an angle or a side, side, side triangle, and we're going to use it to find an angle. So let's find the angle, any angle of this side, side, side triangle. Let's just call this side A, this side B, and this side C. Well, since I set it up that way, then that'll be the labels I'm going to stick with. So when I set up the equation, C squared equals A squared plus B squared minus 2AB times the cosine of C, I'm just going to work with this angle C. So that's the angle I'm going to find. That means this is side C, this is side A, this is side B. So 16 squared is my C squared. That equals 15 squared plus 17 squared minus 2 times 15 times 17 times the cosine of angle C, which we don't know. I am not going to do any calculating yet. Some people are tempted to calculate this and calculate this and calculate this. That's fine, you can. I'm not going to. I like to do that later. The first thing I'm going to do is subtract the 15 squared and subtract the 17 squared. Again, if you want to calculate all this, you can. Some people really prefer that. It doesn't matter. So if the steps I'm taking right now are confusing you, just go ahead and calculate instead. Okay, my next step is going to be to divide everything by this. I can't add or subtract that part. I have to divide that part. So divide everything by -2 times 15 times 17. And that gives me 16 squared minus 15 squared minus 17 squared divided by -2 times 15 times 17, and that all equals the cosine of angle C. Okay, last thing. I'm going to move that cosine C over. We need to find C. Not cosine C, but C. So I'm going to take an inverse cosine of both sides. Do the cosine inverse of this and the cosine inverse of this. The left side gives me a big old thing to calculate. The right side just comes out. These undo each other. The right side just comes out to C. So I'm going to type everything into my calculator now. Now you've got to be kind of particular with this. This is again where if this process throws you off, then just calculate these things as you go, right? Calculate all that stuff as you go instead of doing it all at the end like I am. I'm going to type cosine inverse first. And it gives me a parenthesis right there, but I'm going to add another parenthesis, which you need to do also if you do it this method. And type in 16 squared minus 15 squared minus 17 squared. And I close that parenthesis. See, when you're doing fractions in a calculator, you have to think about this fraction bar like it's a big old parenthesis. The top has to be in a parenthesis, and the bottom has to be in its own parenthesis. So I type divide, and I'm going to do in parenthesis -2 times 15 times 17, close parenthesis. It's all there. Cosine inverse of 16 squared minus 15 squared minus 17 squared divided by -2 times 15 times 17. Let's close off that last parenthesis for good measure. Press enter. Angle C is 59.61 degrees. We found angle C. We used the law of cosines and solved for an angle by plugging in all the sides, c squared, a squared, b squared, a and b. This is in a side-side-side triangle. Now, again, just like last time, we have an angle side pair. So say we wanted to find side B. We could say the sine of 59.61 divided by 16 equals the sine of B over 17. Solve that by law of sines, and we found angle B. Once we found angle B, finding angle A is quite simple. So you should only ever need the law of cosines once if you're solving a triangle. And you should only ever use it in a side angle side or side triangle. Everything else should be law of sines, or it's a right triangle, so you're doing Pythag and Sohcahtoa. You can never, ever, ever solve an angle triangle. You have to have at least one side somewhere to solve something. But what this means is if you're given a triangle with any 3 bits of information, as long as one of those bits of information is a side, you can solve the rest of it. You can find this angle, that side, you can find that side, you can find that angle. Every triangle is solvable if you're given 3 pieces of information, as long as one of those pieces is a side. So I didn't do a lot of examples. I did one of finding an angle. I did one of finding a side. Watch the videos again if you want to see them done again, or feel free to ask me questions. Thanks, y'all. Have a nice day.